Cool. All right. Hey, everyone. Welcome to day 3, module 3. So what we've been doing is continuing to learn JavaScript, but we're doing so by learning Node.js, our server-side option for writing JavaScript. So last week we had started to learn a little bit more about like functions and how those work, but then also use those in a CLI program where we're in the terminal and we can, get some interaction between us and the program itself. Today we'll hopefully finish that, but after we introduce a couple of concepts. So let's get to it. Reminder that the course itself, the course itself on Free Code Camp, there is pre-work that you are kind of expected to keep up with. We're not going to touch every single thing on these, so continue to make sure that you're keeping up and learning different concepts, and then asking questions or coming to office hours if you have any other, any issues with what you're learning on that. There's a lot of resources for solutions on this, but if you're trying to understand something, that's where we can really be of help, I think. Also, remember, we touched on this, but there is a list of coding challenges here at the bottom of the Free Code Camp courses in Module 3, the curriculum here. You can just kind of like actually just Google these, and a lot of the results will be solutions for it. But if you find the actual like this one, for instance. Or we'll just do smallest common multiple Free Code Camp. Then there will be usually a link, but you look at this problem explanation, try and solve it, and then don't look at these solutions whenever you're doing it. Challenge yourself to stumble across it. So these are not expected to be like homework, but we do expect you to do these because most boot camps that I'm familiar with, they like full-time boot camps, they'll actually begin every single day doing something like this. And it's really helpful to kind of just like hone in your skills. So we're actually going to do that today. So I'll close that and I'll open this back up. So we did want to talk about some of the concepts we wanted to cover have to do with debugging. And a lot of that is kind of like feel and experience with programs and knowing the types of issues you're running into. That kind of stuff, like the kind of softer skill and experience, that's going to come both from mostly practice, but also like maybe kind of figuring out like, okay, this is how Zach kind of troubleshot a program, or this is how Devin. That's why we like to come into the class kind of raw, and that's like kind of what we're going to do today. So maybe you can like pick up like how I would debug my own program as I'm writing it. So like I've not actually solved this reverse a string practice problem, but we're going to do that together. And just if you can follow along, I'm just going to talk out loud about what I'm doing. Also, funny enough, just as a side note, this exact practice is often how like a code screening or like initial interview may go if they're trying to do a technical challenge. They're looking for you to explain like, hey, am I doing a good job of thinking through the problem and all that kind of stuff. So it's also great to have exposure to that. So, okay, cool. Yeah, go for
it. So one of the other students says she has to sign in through the browser, and she said she needs the password to the meeting.
Okay, let's see here. Thank you for letting me know about that. I had this hidden.
I think it might be 33122.
33122.
Yep. Yeah, if you click the little shield at the top left, it brings up some meeting information. I've never had to use a passcode to
okay.
join, but
Share meeting info. Let's do this. That's let's, yeah, I see what you're saying. No, no, no. Don't end. Oh, you join? Yeah, sweet. All right, welcome. I'm gonna still close that. If someone else chimes in, please let me know. Thank you for that. Great. Okay, so we just need a function here that is going to reverse the contents of a string. It also retains, you know, the original string itself. So capitalization, that kind of stuff. So just for the sake of time, I'd love to kind of like what we call mob pair or like mob program or pair program on this. But I think we probably wouldn't be able to do that for the sake of time because there's some other stuff we want to get to. I think to me, there's a couple of ways that we can go about this. So one really cool thing, if you remember about strings, is that they act a lot like, you know, arrays. So for instance, and honestly, whenever I was thinking about this problem, I haven't solved it yet, but I was kind of thinking about it and I was like, well, one thing I always do really immediately is I bring up like some sort of console because I can test stuff if I want to. So, you know, like one of the things that I can do is like let test equals hello world. And then I can access, you know, a particular, I can access a particular, sorry, I know that's a little, let's just do this. I can access a particular member of the string or particular, you know, character in the string based on the index, just like I could in an array. So because of that, I could, that tips off to me like, okay, I could use indexes here. So I could create a for loop. So I could do, you know, let I, and I'll go ahead and initialize it. It's always good to initialize and use the let keyword. I'm going to do I equals 0, and then I'm going to iterate, iterate increment by 1 every time, I plus plus. So that means that my I in the for loop is going 0, 1, 2, you know, actually the I is less than 0. This is going to be an infinite loop right here. Or actually it might break out of it after the first iteration. But either way, I need to figure out the condition here. And the reality is I need to go through the string, just the length of the string. So I could do something like, you know, I is less than string str dot length. So what is that going to do? That is going to go through every single one. So I could, you know, just console.log str I, and that's going to do hello. So that's just going to, and this is only one L down here. You can see here, this is the right output. So that doesn't solve the problem. I want to reverse the string. So the other way to do it is I could reverse the for loop, right? So right now we're incrementing up. Well, what I could do is I could do I equals str.length, okay? And then I could do I while I is greater than 0. And then I could do I minus minus. And that's going to be undefined OLLE. So real quick, if anyone's got a guess, why is it undefined OLLE instead of OLLEH?
Is it the space in between the words?
No, the first one I'm getting is just the word hello.
Hmm.
So I typed hello world, but And I'll get rid of this just for to get rid of it.
Maybe 0 needs to be inclusive.
Okay, so let's try that. Undefined. Oh, well, okay, so we got a little bit closer. So we need to include the index 0, the 0th number. So what's the other problem we have? We have an undefined. We have one extra member. Why do you think that is? I'll give you a hint. This is really common that you have to do this. But now we have OLEH, right? And what we had to do is we had to initialize our I at string.length -1. Can anyone tell me why length and the array index is not the same? Sorry, I keep looking down here because that's where y'all's faces are on my computer. I have like my computer down here, so.
The length probably starts at 1 instead of 0.
Boom. Okay, so remember that when you are counting an array member, remember if you wanted to do hello, that string bracket 0, that would get you to H. However, and this comes from like how we as humans count, right? So when we count, we don't start at 0, but when we count, we start at 1, 2, 3. So what that means is when you're counting hello, you're saying HELLO. So that means that the last one, that means that the length is 5. However, if you're trying to access via index in JavaScript, you have to start 0. So that only goes up to 4. So it's very, very common in JavaScript where we have to offset length or the index based on what we're wanting, because those are always going to be offset by 1. And that's always something you have to keep in mind depending on the language you're working with. The first language I ever learned was a 1 index. So meaning I would do for I = 1, I++ or whatever. But in most other languages, it is 0 index. So that's just something that you have to keep in mind and something you'll run into fairly frequently. So what we've done is we reverse the loop, right? So instead of incrementing up, we're now incrementing down. And it's getting cut off whenever we're at 0, which is fine. Honestly, I always like with that type of logic, it's hard for me to like think through. So I usually will just like type it out and play with it until the loop looks right to me. So like if like trying to like, for instance, reason about a for loop like this is difficult, like don't feel like that is like something unique to you. Like even I do that. I just like, I didn't even know if that was going to work. I just, like I said, put something out there and played with it until, it worked. And often the reason for that, for me at least, is that a lot of times I'll use something like if I have an array like this, 1, 2, 3, I'll usually do a dot for each that has a callback inside of it, like an arrow callback, or a dot map or a dot filter, or whatever the use case is, instead of doing an actual for loop. I actually don't do a for loop that often. Another use case for a for loop is a while loop. So where you're counting down, it's often very common where you want to you're taking something away. For instance, we could create this string as an array and then pop the last member off. I'll actually show you how to do that. But for now, I'll show you how to finish this. So, what we're going to do is we're going to do return string. And then we're going to do a return string plus equals stri. And then we want to make sure to return the return string. Oh, sorry, I need to do let. So run the tests. Okay, boom. So what would happen if we did something like this? What would happen there? Well, that really wouldn't work, would it? Well, one thing I did want to point out is just one thing to keep in mind is if I were writing something like this in production, oftentimes what I would say is, okay, I know that I'm using an overload here and this is a string type, but I also want to make sure that I'm being safe about it. You would usually want to make safe code. So because I know that this is that I want this to be a string, I might say like, like something like this to make sure that it gets coerced into a string. But this solves our problem right here. If we were to do something like a while loop, we could do something very similar where we're decrementing like that. But one other way to do that would be, let me see if I can solve this in a reasonable amount of time. So we're going to do let return string. Well, no, so let's do return string equals that. Let original string array equals str dot. So I can turn the string into an array by using the split method. And if you do the split with just an empty string, it'll split everything in it. So if you do like, so I have this test hello world. If I do split like this, notice that it just puts that string in an array. But if I do split like this, then it's going to put every single one of those characters as an array member in an array. Okay. So knowing that, I can do something like original string split. Okay. I could do, I'm just going to comment this out, but I could do something like while original string array dot length is greater than 0. I can do let character, well, const character equals original string array dot pop. So what that's going to do is it's going to take the very, very last in the element in the array element and just return it. And it's also going to mutate the original string. So hello world, once you split it into, like, I'll just show you like this. Get rid of that. Test.split, right? And then if I do let R equals test.split, R is hello world. It's got the D in it. But if I do R.pop, it does not have a D in it. See how it went from 11 to 10? So it literally removes it, but also if I were to assign it like character char equals R.pop, char is now L because that's with the last one. So you can see where I'm going with this, right? So I can construct this array, pop that, and then do something like very similar, return string plus equals character. And then I can console.log return string. And it's going to construct it that way. So that should also do that, do the same thing. So just the difference between for and while is just, that this one is going to iterate differently. It's also semi easier to get into infinite loops with. So any questions on that real quick? Any confusion? Cool deal. All right, so I'm going to close this. Okay, so let's see. Okay, yeah, this is gonna have. I'm just gonna put that there. It's gonna be. This is gonna be from, it's already linked in the README, so we'll go ahead and push that whenever we're done here. Okay, so, last week we wanted to kind of get into this, how do we make like a CLI program, that kind of thing. I think what we're going to do is we're going to jump back into that. We did want to cover a little bit about debugging a program. There's a couple of concepts with that, but honestly, it's better to get introduced to them in context because we will write errors and we have to fix those errors, and it's just better to do it that way, and it'll stick. A couple of things that I do want to bring up though is, obviously we have console.log, right? So console.log is very, very important. Console.log is what we use because we need to always we need to be able to peer into the values of different things. And honestly, console.log is the kind of your baseline. Getting the data and seeing it is one thing, but then figuring out why it's breaking your program the way it was intended is also a different thing. So one thing to also keep in mind that there's this debugger keyword. So if I were to try and run this and I had, let's say, this debugger keyword here, I don't know what this would do in Node, but let's try it. So if I were to do node test.js, oh, I guess it doesn't do anything. If I were to do this in a browser context, it would bring up the debugger in your DevTools. So it would bring this up for you to be able to look in the code as to what's going on. I'm going to mention this. And it's something you can play around with and try in some of your HTML apps that we're building, because I know, or that you've built. And we'll definitely return to stuff like that too. But it's definitely worth mentioning. So the other thing to also keep in mind is there's one of the biggest reasons why you are going to run into issues with your program is because of typing, okay? If you are at all interested, this is why most companies want to use TypeScript and not just vanilla JavaScript. You have to learn JavaScript in order to be good at TypeScript because it's just kind of a superset of features on top of JavaScript. But the reality is that it just takes the cognitive load of having to figure out types, and it can be a pain to deal with, but it also provides some safety for your programs whenever you're trying to deploy stuff at scale. So the biggest way to be able to compare things with typing is the type of keyword. So then,
Hey, Devin,
yep,
sorry, is there any way you can make it just a little bit bigger?
yeah. Oh, that may be good.
Thank you.
No worries. So and part of that too is also how you construct conditionals. So let's say str is equal to this type of str outputs the string of string. Const num equals 0, type of num, And it's got an interesting syntax. It's just type of one word and no actual parentheses. This should output the string number. Did you all cover, in the previous module, did you all cover truthy versus falsy values? Or like what counts as true versus what counts as false, like undefined, null, versus like, or zero versus like, you know, a number, test, or, you know, an object. So this is where it's really valuable to be able to check your types and check things like equality and truthy versus falsy, and then also being able to check things like well, we'll leave that off for now. But the reason I say this is because, you know, if you're constructing something, if, you know, A equals B, you have two variables that you're comparing. I should do A equals. That's actually I've done that, and I've had a program break because I did a single equals. And what A equals, like an assignment will always return undefined, so this will never evaluate. So it's kind of a safe thing, but you know, that's something that you can really introduce a bug really quickly. But I'm going to do triple equals, which you should always use triple equals. Don't use double equals. That's the rule. You can understand why double equals might be used, or you can understand what it does. But my rule is don't ever use double equals. Okay. So when you're constructing things like this, where you're comparing two unknown values, so like I've talked to you before about how a lot of times we've not really encountered this quite as much, but we will soon. You know, a lot of times you don't know what these values are as it's running. So when you're trying to reason about a program, you know, you're in there thinking like, what could these values be? And there's often very many types of values that they could be. So when you're trying to like equate things or compare equality, you have to be able to compare their equality or compare their truthy or falsy values. So the reason that is important is because you can get into things like, so let test one equals, and I'll make this bigger too. Let test two equals object also. What do you think test one triple equals test two is? It's false. And there's a reason it's false, and it has to do with the way that JavaScript like works underneath the hood. Objects and data, like any data object in JavaScript, kind of work in a special way. So you have to understand that you can't just compare objects based on themselves, like based on like the contents of the object. That's a whole other way of kind of figuring, like, of reasoning about that and having to understand what's going on underneath the hood. If I were to do test one equals A and test two equals B, or sorry, test two also equals A, then I can do that again. And it's going to be true, because what we call primitives are different data types that work differently. And then the other thing to keep in mind is that if you want to figure out if something is truthy or falsy, so we have these values, right? True or false, true Boolean, false Boolean, but something can evaluate in something like this as truthy or falsy. For instance, if I were to do if zero, it would never evaluate because zero is a falsy value. It's treated as false in JavaScript. The reason that's important is because or one way that you can kind of test things like that is you can say, you can actually use the not operator, like we call it bang or not, or just exclamation point. So that's going, like, that means that you're negating the value, right? So let's say that you had something like, let's just say test, we'll just do test one again. And it was equal to the value 123. Oh, no, I did double equals. That was my bad. So test one is equal to 123, right? So if we were to do not to double negate test one, we'll get true. Can anyone tell me why that's the case? Just high level. I guess the question would be, what is not test one? If test one is a number 123, not test one is false. That just has to do with the logic of it. Test one is a number, a non-zero number, okay? Because test one is a non-zero number, doing a negation of it, a not, means that it's false. It's treated as a true number, meaning if we were to put it in this if statement like this, it would evaluate as if it were truthy or true because it's truthy. So meaning that if we were to say the opposite of that, it would be false. So what are we doing whenever we do it twice? Well, we're taking the value false and bringing back the reverse of that. So it's, in other words, what's happening is when you do not, you're essentially coercing that value to a Boolean true or false. That is really, really helpful when you're debugging a program, because I may say like, well, my logic's not working right. So maybe I'll just console.log like, not of whatever my variable is to see if it's truthy or falsy. And because maybe whenever I'm doing something like this, it's not clear to me. I don't know. So debugging, what I'm getting at here is when you're debugging a program, it's very important to remember that console.log, you want to see that data. There are debuggers, there are dev tools that you can use. Feel free to, obviously to jump in and familiarize yourself with like Chrome or Firefox dev tools or whatever. There's all sorts of tools out there. I keep learning about new ones every day. And then typing equality and truthy versus falsy, those are ways in which you'll always need to like understand what's going on like in your program in order to make sure that it's like doing the right thing. Okay, because a lot of times a program is just, it's doing something that you didn't expect, but the problem is that computers are dumb. It's going to do exactly what you tell it to do. So you need to use the tools available to you to figure out what's going on. Okay, so that was some new concepts and some stuff that I wanted to cover. You've definitely covered this part before, but it's very important to know, like, this is how I might use these concepts in the context of debugging a program or building a program and getting it to work rightly. Great. Okay, so I'm going to close this. We're going to move over to the CLI again. And what we're going to do is there's several ways to write this program. But the reason I bring us back to this particular article is because we were talking about it, and it's going to be easier for us to teach this part if we lean on this prompt sync package. Okay. So remember what I said last time. In the context of a Node program, so not in the browser, but on the server, we have this idea of Node.js, which comes with a package manager called npm. So if you're on your CLI, you can do a nodes-v to understand what the Node version is, but you can also do a npm-v to see what the npm is. And npm is something that you'll become very familiar with. What happens whenever you create a project? And normally it'll be your whole project, but in this case, I'm just doing it in the days. So just think of day 3 as an entire, its own project, its own program. What you can do is you can do a npm init, and I've already done that. But essentially it goes through some prompts here, and you can just enter through it. If you were to do this, all you would need to do is like enter in this information. You don't need to worry about all of it. But then now you have this nice little file. This file is called package.json. It's very important to be familiar with this, but just know that for now, that's what gets created in the context of a Node program to manage packages with. So what we're going to do is we're going to install this this package prompt sync. So we're going to run this exact thing from here and npm install prompt sync. It's going to do some cool stuff here. It's going to generate a couple other things. So it's going to generate this node modules here. It's also going to generate a package lock.json. These three things right here are what you're going to see in the context of a node package. And what these are doing is it's downloading all these modules for you to use in your program, but it's doing it in a way that is light and to where there's not a whole lot of overlap. So in other words, if two packages are using the same other module, then it'll only download that once. So it creates kind of this graph of like all the dependencies that they have on one another and keeps track of that for you. That's what package lock is doing. That's what the node modules folder is doing. The other thing too is that most of the time, whenever we're talking about like building applications for the internet, it's kind of like, well, all these modules are already out on the internet. Why do I need to download them and all that whenever they're already out there? And also, like, why would I need to, in our GitHub repositories, why do we need to have billions of copies of the same exact code out there? It just seems like a waste of space. And you'd be right about that. So a lot of times what you're going to see is we're going to implement a file called a gitignore file, .gitignore. And then I'm going to do node modules here. That is going to ignore this from Git, meaning when I push this repository, it means that it's going to exclude that entire folder. So you never want to include something like node modules or something sensitive like a security key in your actual repository. And so we're going to exclude that. And then whenever you either like pull this down or if we had like a build process that was going to automatically build our application and put it out on the internet for us, which is very common, we can use this command npm install. And when we install just a single package, we had to specify the package. But if we just use npm install with nothing on there, what's going to happen is it's going to look at all of these dependencies here in this dependencies object, and it's going to create our node modules for us. So the point is that like a lot of times, for instance, whenever I pull code at work, like I have to do an npm install because someone added a package or something like that. And that's just going to keep my local up to date with how it was intended to be run, but they're not going to actually put those in our repo. They're going to just put a reference to it, like in this case, and then I can just run a command to make it happen. So I'm doing all this kind of for us, but I'm just kind of trying to explain some of the concepts while we're going. So I'm going to close that. I'm also going to close that. I have recreated or copied over this CLI program that we had. And we are going to refactor this kind of using what we have here. So let's just kind of do some copying here. So remember that we have first our require or import modules. We still need the std and std out, so we're still going to do that. Actually, no, we don't. Doesn't look like it, do we? So we're just going to do this. And let's see what this does. So this is what packages do. They help you clean up your code, right? So does anyone remember what the command I'm going to run is? It's going to be whatever I want to run the script and then whatever the script name is. Fantastic. So now remember that nifty, it's not module 25. This right here. We can copy something very similar to this. So let's say that we were just going to copy that and copy that here. But instead of window.prompt, we're just going to do prompt on all these. We're going to get rid of that duplicate. We're going to have this function. And let's see, make license. How old am I? 32? I'm not telling you my address. Canterbury Lane. So now we have essentially the same program that we've used both in the window, in the browser, and now we have it here, pretty much the same exact code here in the node place, in the node script that we can now interact with on the CLI. Real quick, I covered npm node and all that kind of stuff in this really quickly. Does anyone have any questions? So I'm gonna go ahead and rename this. This is gonna be like license CLI. I'm also going to duplicate number guess CLI. So I'm going to do that. No questions, no questions, no questions. Please ask questions. You ought to ask questions. Okay, so we're gonna recreate this and just kind of step through this a little bit. So this is kind of fun. So first thing is we're gonna do this. We are just going to take for granted this SIGINT is true piece. The reason that you want this is because let's say that you're let's say that we were to do like if you're in a program like this where it's like running and you don't want to do anything, like you don't want to enter any information, you can do the Control C, right? I think if you get rid of this, that I don't know what that does. I think that it doesn't honor it. Maybe it does. Looks like it works the same no matter what. Let's try that again. Oh, well, we'll just keep it in there just to keep it safe. We want the people to be able to exit out if they want to. So we are going to do this. So, and I took a look at this real quick, but let's just kind of do it like this, where kind of blindly. So we have this number to guess, right? And every time I run this, it's going to create another random number. Yeah. Well, similar to the loop that I created for the algorithm, one of the things I can do is I can create a while loop that's actually going to like use the prompt here to keep this program alive until they guess the right number. So let's say that, you know, we do it like this. So while we're going to do let number or user guess equals, we're just going to do null for now. While number to guess does not equal user guess, const number to guess equals prompt guess a number. Okay. So what's, and then what's gonna, sorry, not number to guess, I don't want to do that. I want to do user guess equals prompt if let's just say if user guess does not equal number to guess console.log wrong. I think this will work. So I guess I don't know what's going on here because I don't know. No, this is wrong. So wow. Okay. I have to be completely transparent here and say that this was not intentional, but this is exactly the thing that we needed to go over, that we wanted to go over. I was just going to introduce this artificially, and I happened to introduce this to myself accidentally. So at this point, 2 is equal to 2, which means the while condition is actually false. When a while condition hits false, it's supposed to break out of the loop entirely. And also, if this was false, we wouldn't be seeing this because it's the same condition, right? Can anyone tell me why it's not breaking out? Why it thinks that my guess 2 is wrong, even though the number that it generated is the number 2? How should I go about debugging this program? Let me ask it that way. I'll give you a quick hint. The hint is in the color of the numbers. No one?
They might be different types.
Okay, I like it. So you could be onto something because they're different colors in the CLI. That makes sense. So let's see. We're gonna have to kill this. Look at that. So I don't know what the value is that I need to guess, but what I'm seeing is that when I'm consoling.log, I have a string and I have a number. Interesting. Okay, so how can we fix that? Well, I think one way we can fix that is to make one the other. I think it's probably if we know that what people are inputting is supposed to be a number, then maybe we just convert that into the type of a number. So then the user guess, we can use that. So with JavaScript, I want to point out a couple of things that are going to be important. You know, there's when working with numbers there in computers, there's specific types of numbers and way we work with numbers. Those of you who hate math, but still want to learn a program, like I'm not saying that you absolutely have to know math. I think that knowing math is super helpful. And there's plenty of like UI and UX engineers who are really, really awesome. There's plenty of people in tech who do not know math well. But specifically when working with kind of the data side of things, right? So right now we're working with data because like we're comparing values, that kind of thing. We have concepts like we have this math object, which has math.floor. Essentially what's happening here is this is converting what would normally be a decimal number to a what we call an integer or a like non-decimal number. So that's what math.floor is doing. This is just randomizing it at a base of 10, and it's it's adding 1 just in case that it's at 0, because we want it to be 1 through 10. My point is that we know that this is supposed to be an integer. So because of that, we can use some special JavaScript like global functions in order to make this happen. One is if you want to make something into a number, you can use what's called parse int, parse float. Float is another word for a floating point number or a decimal number in JavaScript. So you can parse float, which means that you're gonna, like if I had a string that said 123.456, it's going to, convert that into an actual decimal. Or if I had, like an integer, like 123, it's going to parse float is going to convert that to 1.3.2.200. In our case, we want a we want this to be the case. We want to convert it from a string or from in another instance, it may be another type of number, but we want to convert it to an integer. So for instance, if I had like, I'm going to pull this up, like parse int 123.456, it's going to convert it to 123. If I wanted it to go if I wanted to round it, I could do like a rounding, or I could do, where I always round up or always round down. That's what math.floor or math.ceil is, like that floor or ceiling that's like always rounding up or always rounding down. So there's a lot of different functions for you to work with math and work with numbers in here. In our case, really what we want to do is we just want to be able to convert something to a number. Parse int is a really, really good function for that. We could also convert something to number, but because we want an integer, we're just going to use parse int. So let's see what this does. And then we're going to just do type of user guess and user guess, and then type of number to guess and number to guess. Okay. Gonna exit out of this part. Gonna exit out of this part, rerun the program. Okay, so number now. Okay, so what's going to happen if I do 4? It's going to exit. I mean, which is the same as saying like else. Right. We could do something else interesting here. We could, count the number of times that the person guessed or whatever, and say that they only have so many amount of guesses left or whatever. But you kind of get the idea. So now we have this nice, and let's actually just make this good for our user. And then do, we can do like a user guess. well, I can do number to guess. It doesn't really matter because they're equivalent at this point, right? But oh, cool, it's 3. Very good. Okay. Any questions on what we went over on that? Anything that felt like it was unclear or anything like that? This actually ended up being a great program to kind of explain some concepts that we introduced, and we got to make progress on our CLI. Cool. Remember, so debugging, we want to make sure that we're checking our types. Typing is almost the #1 way that you're going to break a program. Console.log's your friend, always use it and look at the console. We kind of went over, like for loops and while loops, which we ended up using in our little number CLI. With Node, we're able to use npm, which means that we can pull in all these other packages, and those packages might have other packages that they're using. So, we did an npm, actually did an npm init on this folder here, module 3, day 3, and made this as if it was a Node project. It has package.json, but really the idea is we just wanted access to this require prompt sync. And this, you don't always necessarily have to do this, but I know that because of the article. That's honestly the article. I just copied and pasted, right? So then we were able to make almost like for like. We just had to get rid of the window dot, the license program that we had created, but now we have it in a CLI. And then we created a little number guess CLI with the same package, and we were able to kind of use some of our debugging and typing to kind of figure out why this program was not considering these to be the same. And now we have access or some concept with these numbers and math concepts in JavaScript and how we work with those. So I feel like we covered a lot. I do want to check with theirs. So, okay, so this is how they do it, right? So they use a flag here. This little flag is just, something independent. It's an independent variable. But so what I did is I just compared them directly, right? But you can use a flag there. There's a word for that. There's a word for like a true false flag that you use in a setting like this. But anyway, so we do, while it's not the case, we're going to get it, we're going to convert it, we're going to compare it. And then if it's true, then we can trip the flag, which tripping the flag is what's going to cause this to actually break out. So it's interesting. Compare and contrast a little bit, the solutions here. I'm not saying mine's better, but I will point out that mine is shorter by probably 10 lines or so, I think. They have comments, so that's not necessarily fair. But, and by using the comparison of the values, I actually didn't introduce a potential infinite loop where you could never break out of this while loop. Because had you forgotten this line, you would have been stuck in the program. It would have told you, yes, you got it and congratulations, but it would have not broken out of the loop. So I don't know. I mean, I think I like this because you're not having to repeat yourself, but also mine's shorter. So I don't know. You're gonna run into that a lot. People solve problems different ways. So all right. Any questions? I'm going to stop recording now.